Hello there, ATS 114 students. Dr. John Schrage here, and today we're going to be learning about weather map analysis in Lab 9 of the lab. I can tell you this is one of the very favorite things I like to do in this class. I love weather maps. If I could just live on a desert island and work with weather maps, I totally would do it. We're going to be doing a couple of different little parts of this activity that involve weather maps. One part right at the beginning involves decoding station models. Remember, station models are that little cluster of symbols that we put on a weather map by each weather station that gives information about things like the temperature and the dew point and the pressure and the current weather going on and so on. That little part of the activity is really not that big of a deal. There's a key that kind of helps you understand how to decode those symbols. I think it's on page 103. If you go to Appendix C way in the back of your lab manual, there's lots of other symbols provided that will help you decode how that symbol works. An important thing that I think it doesn't really stress is to remember that that little flag that points off of the wind barb there, I'm sorry, off of the station model there, that's called the wind barb, and the wind barb points upwind. Again, you'll see some examples of this in just a little bit. So between the key on page 103 and the appendix at page, I think it's 244 in your lab manual, you should be in good shape on that. Now, a slightly trickier skill to learn in this particular lab has to do with contouring weather maps. Drawing those lines that we've been seeing all throughout this lab manual and all throughout ATS 113, how to actually draw those things, how to actually produce maps that illustrate weather information. So what I've done here is I've actually kind of made a fake example that's quite similar to what you're going to be doing in the lab activity, and I've just sort of put some fake temperatures across the Midwest here to kind of illustrate what I'm trying to do here. What I want to do on this map of this fake temperatures here is to draw a set of contours. The contour lines that you draw on a weather map have names. In the case of a map that illustrates temperature, those lines are called isotherms. Iso is a prefix that means equal, therm, temperature. So these are going to be lines that illustrate constant temperature, and they really mean that. There's going to be a contour line that represents, let's say, 70 degrees Fahrenheit. And everywhere on the line that is 70 degrees Fahrenheit, the temperature is 70 degrees. On one side, all the temperatures are less than 70 degrees, and on the other side, all the temperatures are more than 70 degrees. Let's actually use 70 degrees in our example here, since we can see that we have a range here of like, what do we have, 58 degrees in North Dakota to as little as, as much as 91 in Ohio. All right, it's not so hard to picture how to draw the 70 degree isotherm, say across northern Wisconsin and down towards Minneapolis, because the temperature is exactly 70. Our 70 degree isotherm should cut right through those cities because we want every place on that line to be exactly 70. The question is, what do you do then? How do you keep drawing the contour line so that it continues to separate places that are more than 70 degrees from places that are less than 70 degrees? Well, I want to continue extending that line towards the west in this case, and I see that that place in eastern South Dakota has a temperature of 65, whereas Omaha has a temperature here of 77. Clearly, someplace between that station in South Dakota and the station in Omaha, someplace in between there, it must be 70 degrees. And so I put the line in there between. You want to be better, it's hard to do this in PowerPoint the way I have it here. You want that contour line to be closer to whichever station is closer to 70 degrees. If I was drawing this better and by hand, I would have made it so that my contour line actually got a little closer up there to that station in South Dakota and a little farther from that station in Omaha. But again, drawing these kind of lines on PowerPoint and rendering a video, it just never quite works out exactly the way you think. And the same way we could continue drawing that line. See, like for example, Scottsbluff in western Nebraska has a temperature of 67, whereas I think that's Grand Island had a temperature of 79. So we want someplace between Scottsbluff and Grand Island, it must be exactly 70. Okay, so we have our contour line there, and then when you get to the end of the map, we just stop. When you draw your contour lines, make sure you start and stop, if at all possible, on the edges of the map. And your line should separate areas that are more than, in this case, 70 degrees from areas that are less than 70 degrees. See how every place north of this line, 67, 65, 68 degrees, etc. And everywhere to the south of this line, 71, 75, 91, 79, they're all greater than 70 degrees. We could do the same thing with 80 degree isotherm. It's not so hard to see that it goes through central Michigan. There's a station right there that is exactly 80 degrees. But like as we cut across Indiana and into Illinois, well, okay, Chicago has a temperature of 79, Peoria had a temperature of 81, so clearly the isotherm needs to, someplace between Chicago and Peoria, the temperature is 80 degrees. So we're going to cut through there about halfway in between the two. Again, like if we keep cutting across Missouri and towards the west, I see, for example, Omaha has a temperature of 77, and I think that St. Joseph has a temperature of 81. So clearly someplace between Omaha and St. Joseph, the temperature is 80. Again, if I was drawing this by hand, I'd be more careful to make sure my isotherm for 80 degrees was closer to the 81 than it was to the 77. But again, that's really hard to control in PowerPoint. And then I just keep cutting across. Again, in this case we have to take kind of a sharp left turn because we need to get it between the 77 degrees in central Kansas and the 88 degrees in southwest Missouri. Again, this time I did a better job of making sure that my isotherm cut closer to the 79 than it did to the 88, because 80 degrees is probably closer to the station that is temperature of 77. And we can keep doing this, and we want our contour interval, the gap between contours, to be the same. So if I had a 70-degree contour and an 80-degree contour, my contour interval is 10. So let's draw the 90-degree contour. Well, in this case, there's really only one station that we have to kind of separate from the others, that station in Ohio. Okay, it is more than 90. It should be on the warm side of the 90-degree contour. All the stations on the other side of the contour are less than 90. And in the same sort of way, I want to draw a 60-degree contour. In this case, I need to go by my contour interval below 70, and I see that there is a 60-degree contour. I got to separate stations that have temperatures less than 60 from stations that have temperatures more than 60, and there are no temperatures on this map less than 50, so we are done. These contour lines take some practice to draw. Just to give you some basic guidelines though, they cannot cross. Isotherms cannot cross. None of these iso words that we're going to use today are lines that can contour lines that can cross. Because remember, on the 70-degree isotherm, every place is 70 degrees. Well, if it crossed the 80-degree isotherm, then there'd be a location where those two crossed where it is both 70 and 80 degrees. Well, that can't work. Your contour lines should be as smooth as you can make them. That takes some practice. The first time you're doing them in ATS 114, you're probably going to draw fairly jagged little contour lines. And it's not the end of the world, but aim for them to be kind of smooth and flowing. They should start and end at the edge of the map. And there's always a temptation to kind of trace around the edge of the map and make them into loops or something. Don't do that. If you start at the edge of the map, go to the other edge of the map. And an important point is to make sure that your contours are always labeled. Don't have any unlabeled contours on your plot. That just makes it harder to read. The kind of contour that we drew so far in this activity was an isotherm, a line of constant temperature. But actually, you can have all kinds of different contours. Contours of pressure, like to illustrate where cyclones and anticyclones are called isobars. Remember, bar is a suffix that means something like weight. Okay, so that would apply to pressure. Isodrosotherms are the lines of constant dew point. You do draw some isodrosotherms in this class. I think it tells you to draw them with dashed lines on some activity. Isotachs are lines of constant wind speed. They're contours of the wind speed, and you'll be doing that in this lab activity. But there's actually tons of different kinds of weather maps you can make, and all of them with these kind of contour lines, and all of them start with iso because they're lines of equal pressure change, height. In fact, this is a book called The Glossary of Meteorology. It's kind of a handbook for meteorologists, and it's often referred to as the ISO book because it's a dictionary of meteorology where I happens to be the fattest letter. I happen to have it open to the ISO, one of the pages of, it just goes on for pages and pages of different kinds of weather maps that start with ISO. Isogons, isogeotherms, isochrones, isoclines, isoheights, isohyets, isokinetics, isoalahipses. It just goes on and on for pages of all the different kinds of weather maps meteorologists can make using these kind of contours. There's a couple more things that we do in this lab activity that I do want to draw your attention to. You're going to have some plots that show these wind barbs, similar to what I have going on here on this diagram. And it's going to ask you to draw some streamlines on there. All it wants you to do is kind of draw a line that's parallel to these wind barbs, going in the direction the wind barbs are going, and, end it with an arrow. And then I think it says to draw several, so maybe go for like 3 or 4. Again, this is hard to do in PowerPoint, but you want to just sort of follow for a while and then put an arrow on the end, follow and start it someplace else, follow those wind barbs for a while, put an arrow on the end, do another one, do something like 5 or something like that, and you'll illustrate the circulation of the winds right now. Like this is clearly a large cyclone out there over the North Pacific at this time that this plot was made, where we have the winds spiraling in, converging towards an area of low pressure, and notice how they are spiraling in a counterclockwise way. This is a cyclone. One last set of plots that it's going to have you draw is isogons, contours of wind speed. Now, I found this diagram online that sort of illustrates it. They're using, again, just like you will in your lab activity, rather than actually giving you the wind speed like as a number, you're going to use the wind barb itself. And if you go to your appendix of your textbook, I think it's page 244, not your textbook, your lab manual, you're going to see that there's a code to how those little flags and pennants on the end of the wind barb tell you what the wind speed is. Every pennant, the little triangles that are on the end, is 50 knots, and every bar called a flag on there is 10 knots. So you just add them up and you can see, oh, this station has 2 pennants and 1 bar, that's 110 knots. A knot is a unit of wind speed, it's a nautical mile per hour. Now on this particular diagram here, they actually have shaded in different regions of different wind speeds, but like I could draw in here by tracing those, the areas that had wind speeds greater than 70 knots from wind speeds that are less than 70 knots. You can see how I actually just separated wind speeds that are slower from wind speeds that are faster using that. And in this particular diagram, they used an interval of 40 knots. So if wind speed is 70 knots in that first contour, the next contour I should draw is 110 knots. And so I can see that there's areas of wind speeds greater than 110 knots. This is at that's a 300 millibar level. This is about 10 kilometers above ground. The rather strange numbers here of why 70 knots, why 110 knots, this is actually a chart that they use in aviation. Pilots use this to find jet streams and things like that. But I think you're going to have a slightly different purpose to the diagram that you use in the lab activity. Okay, I think that's about it. It's just a fairly straightforward exercise in learning the skills associated with how you produce a weather map. There's a handful of questions you don't do. There's 3 or 4 questions along the way that are way too hard. Make sure your TA communicates to you which questions you do not do, and I'm sure your TAs can answer any questions. Good luck, and I'll see you next week.